Thank you for the introduction. Good afternoon, everyone. Thank you for joining me today to learn about alternatives to conventional F2 testing for dissolution similarity, F2 bootstrapping, and multivariate statistical distance MSD method. Before I start, here's the standard disclaimer. This presentation reflects the views of the author and should not be considered to represent FDA's views or policies. The objectives of my presentation today are to understand and describe the frequently used statistical approaches for dissolution profile similarity assessment in bioequivalence determination, and to understand how to apply F2 bootstrapping and MSD method for dissolution similarity testing through case studies. As we know, in vitro dissolution profile comparison is important for the evaluation of generic drug products, and it can be applied to demonstrate similarity between a test and reference product, to support the biowaiver for other strengths based on B of biostrength, to support BCS-based biowaiver, so on and so forth. Dissolution profiles may be considered similar by virtue of overall profile similarity and similarity at every dissolution sample time point. As per the FDA guidance recommendation, the dissolution profile comparison can be conducted using model-independent methods, including similarity factor F2, multivariate confidence region procedure, and model-dependent approaches. Today's presentation focuses on model-independent approaches. The model-independent approach F2 testing has been considered the most widely applicable method for assessing similarity between two dissolution profiles. Talking about F2, the equation shown here illustrates how F2 is calculated. The following bullet points highlight the important dissolution data requirements for applying F2 method. You need to have 12 units for each product, minimum of 3 time points, and only one measurement should be considered after 85% dissolution of both the test and reference products. Measurements should be made under the same condition, and the dissolution profiles should have the same time points. For example, at 15, 30, 45, and 60 minutes. Whatever test products have, reference should have the same. There are requirements on variability for applying F2, and we will discuss this on next slide. To interpret the result, F2 value of 100 indicate the mean difference of dissolution profile at each time point is 0. When the F2 for the mean test and reference profiles are greater than or equal to 50, the two profiles are considered bioequivalent or similar. Specifically, the requirements on variability for F2 calculations are the percent CV of dissolution data should not be more than 20% at the earlier time points. At other time points, the percent CV should not be more than 10%. Otherwise, the dissolution data is considered highly variable, and the current regulatory practice for highly variable dissolution data are model-independent statistical methods. The most commonly used ones are F2 bootstrapping and MSD method, also described as model-independent multivariate confidence region procedure in the dissolution guidance. I want to point out that this presentation focuses on the two methods. However, in practice, it is not limited to these two methods, and there are other procedures that may be applied. F2 bootstrapping is a relatively well understood technique and provides a simple answer that most people can conceptualize. This slide will summarize the steps of F2 bootstrapping. The first step is to generate bootstrap samples by resampling with replacement from the raw dissolution data for the test and reference products. Second step is to estimate F2 for each of the bootstrap samples. After that, by taking the average of F2 values calculated from all bootstrap samples, the bootstrapped F2 mean can be calculated. And 90% confidence interval of the bootstrapped F2 can be calculated using the percentile method, and BCA approach may be applied to correct the bias. From our ANDA review experience, we have found that the bias was relatively small for the dissolution data. That is to say, although the assumption that the bootstrap distribution was symmetric and unbiased might not be met in some cases, BCA intervals were very close to percentile intervals in most cases. And the same conclusion could be drawn from these two intervals. The MSD method discussed in this talk is based on Mahalanobis distance, calculated by the equation here. And from the equation, we can see that the differences at various time points are weighted by the covariance matrix, a combination of variance and correlations, so that both the mean dissolution profile and the variability are considered by calculating Mahalanobis distance. This slide will summarize the steps of MSD method. The first step is to determine the similarity limits by calculating MSD based on interbatch differences in dissolution from reference batches. The next step is to estimate the MSD between the test and reference mean dissolution. And from there, 90% confidence interval of the true MSD between the test and reference batches can be estimated. Finally, using the results calculated from the previous steps, if the upper limit of the confidence interval is less or equal to the similarity limit, or as the simplified 2D illustration shows here, if the blue region is within the orange region, then the dissolution profiles of the test and reference are considered similar. And different from F2 method where the common acceptable cutoff is 50, the cutoff for MSD method is data dependent. Moving on, I will go over several case studies to show how F2 bootstrapping or MSD method was applied and how the results are interpreted. For case study 1, the drug product A is a locally acting drug. Its product-specific guidance recommends in vitro study as one of the options to establish bioequivalence, which include comparative dissolution testing under multiple pH conditions. pHG requires at least 12 units each of the test and reference products should be tested. First, look at the test under pH condition 1. Look at the data that shows the within batch variability. For test and reference, at early time points, 5-minute and 10-minute, the percent CV is pretty high, greater than 20%. And for test product, at later time points, at 20 minutes, the percent CV is still high, greater than 10%. And this indicates the data is highly variable, where the F2 testing using the mean profiles was not applicable. So F2 bootstrapping was applied for the dissolution profile comparison of the highly variable data in this case. Same as F2, for bootstrapping F2, the common acceptable cutoff is at 50. As the results shown here, both F2 bootstrapping mean and the lower 90% confidence interval of test versus reference data were greater than 50. So the two dissolution profiles of test and reference are considered similar. Now look at the test under pH condition 2. The dissolution data is highly variable, indicated by the large CV in red highlight, and bootstrapping F2 was again applied. The results show that although the bootstrapping mean is greater than 50, the lower 90% confidence interval is only 44.82. So in situations like this, larger dissolution profile difference between the test versus reference may be acceptable if the reference versus reference difference is large, meaning that the reference may be used to justify the lower test versus reference F2. A quick note is that here for the reference calculation, we notice that the sample size is 6, as 6 samples were randomly selected without replacement from 12 reference units and compared to the remaining 6 reference units. However, from the results in this case, the test versus reference F2 is still lower than the reference versus reference F2. So the conclusion is the dissolution profile of test and reference are not similar. Through case study 1, we looked at how the dissimilarity conclusion was drawn by comparing bootstrapping F2, 90% confidence interval lower bound, for test versus reference to those comparing reference against itself under the same condition. The option for the applicant is to repeat dissolution testing on the proposed test products with a larger sample size to provide a better estimate of the mean difference. Specifically, the testing should be conducted on at least 24 units, more if necessary, of the test product, and at least 2 lots of the unexpired reference products with 12 units per lot. Now moving on to case study 2. In this case, drug product B is an extended release drug with multiple strengths. Its PSG recommends in vivo studies on the biostrength, which is the middle strength, and as one of the criteria for justifying the waiver request of other lower and higher strength, the PSG recommends multimedia dissolution testing under a range of pH conditions. For one of the dissolution testing under pH condition 1, the reference products are products of biostrength and the test products are products of strength 1. Looking at the data that shows the within batch variability, the percent CV is greater than 20% at early time points and remain high at other time points. When we eyeball the mean dissolution profile, the apparent difference somehow implies the dissimilarity. And for this application, the model-dependent approach, specifically Weibull modeling approach, was proposed by the applicant, but was considered inappropriate. In FDA dissolution guidance, it is suggested that in instances where within batch variation is more than 15% CV, which is the case in this application, a multivariate model-independent procedure is more suitable for dissolution profile comparison. As a result, multivariate model-independent approach, MSD method, was then applied. Bootstrapping F2 was also applied. And here's the result. We can see that bootstrapping F2 fails largely with low bootstrapping mean at around 37 and lower bound of 90% confidence interval at even lower value, indicating the dissolution profile of test and reference are not similar. Results using MSD method, however, indicated similarity. So currently, both F2 bootstrapping and MSD method are frequently used when the dissolution data have high variability. And we have observed that the results between these two methods may not be consistent in some cases. And as found in literatures and agencies' internal research projects, bootstrapping F2 may be relatively conservative compared to MSD method. The consideration is that the biowaiver request should be supported by the totality of the submitted information, including dissolution profile similarity testing. So for this application, other deficiencies were identified, and the option for the applicant is to reformulate the test products and repeat dissolution testing. Now we come to case study 3. In this case, drug product C is an immediate release drug. Its PSG recommends in vitro study as one of the options to establish bioequivalence, which is to compare 3 lots of test products with 3 lots of reference products using an optimized quantitative capsule rupture testing QCRT method. The figure shows the mean dissolution profile for each lot. Looking at the data, except for reference lot 2, high within-batch variability were observed for all the lots. Test lot 3% CVI at 10 minutes is substantially high as 71%. Because the data are in multiple lots, different strategies can be used for comparisons between test and reference. One approach is to compare the pooled data using 12x3, 36 test units versus 36 reference units. The variability of the pooled data suggests that it is still highly variable, and the bootstrapping F2 was applied. Bootstrapping F2 result its mean and the lower bound of confidence interval are both low, regardless of using 50 or reference versus reference F2 value as acceptance criteria. So the conclusion is that the dissolution profile of test and reference are not similar. Another approach for multi-lot data is a pairwise lot comparison, and the sample size is 12. The results show that none of the test versus reference F2 values are above 50. And if using R2 versus R3 as the acceptance criteria, only T1 and T2 are found to be comparable to the reference products. For the remaining test versus reference, the F2 and lower bound of 90% confidence interval values are lower than those of the standard for reference versus reference comparison. And in this case, MSD-based methods were also applied and showed a lack of similarity. The results from both methods indicated that the dissolution profile between the test and reference are not similar. And the option for the applicant is to develop the new discriminatory QCRT method or reformulate the test products. Here, I will summarize the take-home points. Guidances, including general dissolution guidances and product-specific guidances, reflect the agency's current recommendations for dissolution profile similarity testing. Conventional F2 is a basic tool for dissolution profile similarity assessment. In the case of highly variable dissolution data, appropriate statistical methods should be applied to evaluate the dissolution profile similarity. The commonly used ones are bootstrapping F2 and MSD method. Regulatory guidance provides principles of dissolution testing and general recommendation of these statistical methods for dissolution profile comparison. Other methods not specified in the guidance may be acceptable if robust and scientifically appropriate justifications are provided. And I would like to emphasize that potential applicants are highly encouraged to proactively reach out to OGD and discuss the alternative approaches. Here are the relevant guidances and references cited in this talk. So we're almost done. Here's a knowledge check from earlier presentation. Which of the following statements is not true? A. F2 of 100 indicates that the mean difference in the amount dissolved at each time point is 0. B. Dissolution profiles are considered similar if the upper bound of 90% confidence interval for the bootstrapped F2 is greater than or equal to 50. C. 3 or more dissolution time points are needed for F2 calculation. And D. MSD method is a model-independent approach for dissolution profile testing. I will leave you a little bit of time to think about it. The answer is B. It is incorrect. As mentioned earlier in the presentation, dissolution profiles are considered similar if the lower bound of 90% confidence interval for the bootstrapped F2 is greater or equal to 50. Finally, I'd like to acknowledge my colleagues from Office of Research and Standard and Office of Bioequivalence within OGD for all the support I received on this presentation. I would also like to thank colleagues from OB and Office of Product Quality who are involved in the relevant ANDA reviews. Thank you. This concludes my presentation. See you later in panel discussion session, and I would be happy to take questions you may have. Thank you for your attention.